In one of the enclosure videos, I mentioned the top-down assembly strategy, that if you had parts above a certain number, there's going to be a comfort level that you would want to consider going over to an assembly version. So let's go into the assembly inch or the default assembly, and we'll pick some geometry. So to begin the assembly, right now we're starting the command when creating a new assembly. So for this, I just want to go ahead and close it. I try to make it a habit. I don't always succeed or remember, but with a top-down assembly, best is to save immediately. So pick a name, decide on a name that you'll be happy with for a long time, because it's kind of a pain to change it. And I'm just going to call this Enclosure Top Down or something to that effect. So save. And one of the things I'm going to work with is the layout sketch. So there are a couple different ways to strategize. I prefer to go with the 3D sketch kind of in the feature tree rather than the layout. If the layout is going to be the only 3D sketch, then it's pretty functional. We're going to do a quick test, because the last couple times I did the layout sketch and then I tried to place 3D sketches over top of it, there was still a bug, an error, an anomaly in the software that we couldn't get back to the layout sketch. So for its purposes, I'm going to go with the create layout. I want to be in the top plane. So this is acting just like our other 3D sketches. There's some additional things, making the part from the block, having that top-down functionality, where inside of a part we can do quite a bit with some of those block tools. There's a few that only work in the layout. So some of the what would be considered the mechatronics, or the actual movement dynamics of parts, we can utilize in the layout. So if I was doing a gear set, I could make my 3 or 4 pitch diameters and see what the net result of the rotations are, for example. So in this case, I'm going to go with the we're going to stay in the front plane as the default. Again, with 3D sketch, if you double click, now you're in that floating origin. If you come over to any of the planes and double click, now you're drawing in that plane, and you have a lot of the 2D sketch functionality. So I'm going to go with a midpoint. I like that symmetry, and we'll get some dimensions on this. So I'm going to stay with the basic sizes. This 36 by 16, since we're going up. If I go to the isometric, then my depth would be going back the other way. And so I'll go back into the top plane, and notice this grays out because it has on-plane relations. I can still pick it up, but I'm sort of limited into what I can do with it. So I'm looking for my vertical, and then the horizontal. Maybe it'll give me an inference line back to the point. If not, we'll pick those up with the dimensions and our geometry. So 24, everything goes fully defined. Right. And let's see, I had a vertical, we had that on the top, so we can double click, everything becomes apparent. But when I pick on these, we're going to see that horizontal on plane. And again, that's just kind of helping with the rotation, that things aren't going to get all weird before we get a chance to get this fully defined. Alright, so got those. I'm going to go ahead and connect the dots. So even that floating origin, as long as I'm connecting point to point, it looks like I missed that one, it's not going to have any issues. So we are going to see that little bit of angle. So I could make the 4 verticals equal, which would have the same effect. I don't think I got it to do this on the original enclosure sketch. So Since all of the lines were equal, that kind of took care of the along X, the along Y, and the along Z. So along Z says that that is going to be parallel to the plane, perpendicular to the front plane. Basically looking at the reference triad in the lower left corner, we're along Z. And then we can go with along Z again. Alright, so didn't really like that one. So quick Control Z on the keyboard. Let's see if we can go with an along X. Alright, so one of those temperamental. And so if I were to pick, let's go with the one with the dimension and set those to equal, I get that result. And the along X, Y, and Z is there, but at some point it will get to a level of complexity that it's not happy. So my gut is that with the layout sketches, drawing that that wireframe prism, almost looks like something got missed there. That wireframe prism, we're going to go in and do the 3D sketch for the for what would be the other items. So you know, kind of the mix of 2D sketches. If you need a 2D sketch, put it in there. I think that maybe the 3D sketches have some advantages, and you know, really, I've said it before, say it again, that you know, there is no right and wrong way. There's things that are going to take longer or be a little more efficient, but the real test is the validity of the end model. Is that if you get the desired result and you learn from it, then it's just part of the process. So I'm in the 3D sketch, it's telling me, and so we can put in that center brace. And so this is one of those, the origin's going left to right, up and down, but if I go look for that midpoint, it's going to override. So I get that segment in. Let's go to the front plane, and I just want to have a 1/4 inch for the base. And the intent is that we'll be able to drive some of these dimensions and get it into a situation where most of the geometry comes from these initial sketches. So in this case, the geometry wasn't that complicated. I don't really need this second sketch. It's more of a test of what happens to my layout. So let's go ahead and save. And from the layout, then, do not see the sketch, so we'll right click, and I'm going to hide the layout so that I have just those lines. And then if I come back to the very top and right click and show layout, okay, I get that back. Alright, so in previous versions, probably up through at least 2017, at some point this outside wireframe would stop showing up. So we're gonna test it. Alright, so going forward, this is now my envelope. Well, not really, the layout sketch is the envelope. So maybe I put this into a support role and be able to drive that geometry. Alright, so now we get to the top-down portion. Alright, so where in the multi-body we just started in on weldments, here we're going to separate out the sheet metal and the weldments into separate parts. They can still be included. Probably, you know, for the most part, the weldments really just need to be in that one file, unless trying to think of an instance where you get into, there's a lot of different sizes, but from a purchasing and a building standpoint, staying common, those elements of commonality with the materials, that's gonna save you a lot of trouble. So where the weldments had the half or the 3/4 L and the shape across the bottom, those are plenty functional. And I'm still going to have to reproduce this. I'm not planning on putting my geometry directly on this sketch from the assembly. I have to reproduce it in the derived, in the new part. Alright, so we're going to go in, create the part. I don't like picking the plane, so I click out and it's going to follow the same origin as the assembly. If I pick a plane other than the front, I believe, then that's when it starts skewing the origin. That always freaks me out, so I usually just end up clicking somewhere and saying it's in that orientation. I don't have to worry about it twisting on me. So weld. And with the brackets, that tells me that this is a virtual component. It does not exist outside of the assembly. So next step is to edit the part. And then now, when I go into the 3D sketch, everything's kind of shifted over. We go into the 3D sketch, and I just need the elements for my geometry to apply. So probably won't go through, in the interest of time, I probably won't go through the entire, let's see, we left a little gap there. So I'm going to include that. If I think about it or I know I'm going to want it, then it saves trimming it out later. So that was that center support that is going to, well, I'm either going to have to trim it or I'm going to have to leave some room for it to span those legs of the L bracket. Alright, so that and that would be equal. And then I need a material thickness, which I could tie in equation somewhere or pick it up. And since I don't really want it to be able to participate, I'm also going to make those into construction geometry. Alright, so zoomed out that far, it's kind of hard to see. We have to zoom up a little bit to get even a little hint of the dash dash. Oh, and then in the process, I missed that one. Okay, so I think I've got them. You rotate around, it's not doing anything weird like I sketched it in a 2D plane. Notice that my 3D sketch has the dash greater than symbol that is referring back to the other geometries. And so now if I come up and I hide the support, or I go back and hide the layout, then I know I'm only going to be picking from the sketch. It should do a pretty good job of not grabbing those items, but somehow I never know. Alright, so for the weldments, we're going to go through the same structural member. The square, we used half by half on this one. Let's see, we created the custom, was actually looking to see if there was a 3/4 by 3/4. Was interesting if I move that up, if it would go, what kind of impact it would have on the weight. Well, we'll stay with the 1/2 inch. And the group. And we set it. We locate the profile. I'm going to put it on the interior. Okay, so it picked that up. Looks like it picked that up already. And it's in the correct orientation, so new group. So maybe we'll just do the verticals and maybe the one in the flat. Alright, so locate on the profile looks pretty good. We just need to rotate it, and so that should be 90, going the other way. So 270. Alright, and then another new group. And we'll just keep coming around the piece and rotate. See which way it goes. That looks good. And as a general rule, if I pick on the bottom side, I should get all those layouts. Well, made a liar out of me right away, so I was expecting them all to be on the bottom, but then I picked that one low and it went up top. So I would like to say there's a method there somewhere, but we'll get it. Alright, so that becomes my angle. I would go ahead and put in the other angles, do the miters, do the cuts, whatever we needed to do for the sides, and get that all trimmed out. The other piece for the weldment, oh yeah, and then we need to switch over to the bar. Alright, and then we'll locate the profile, and I'll put that sub and flush. Alright, so you get the general idea of the weldments. I accept the weldment part. I have the geometry. If I want to hide everything, then I can go back and hide. And we'll go back up to the layout and show the layout, and we're still getting it, so that's looking good. Alright, so quick control 1. Alright, so for the sheet metal you have the choice of, again, if everything was conveniently the same size or not that complicated. As we got into the more complicated bends, I would probably have a part sheet metal 1, part sheet metal 2, go through the entire structure so that I could keep track. Since these are still very boxy type pieces, then I can include it all in one part, and the sheet metal cut list, the sheet metal table, and bend table won't be that complicated. So same thing, new part, pick my template, pick a location out and away from any of the planes, and then this one's going to be the sheet, and then I can edit it. Alright, and then because of the way I chose to do this, let's go with the front plane, and we did pretty good on the multi-body already, so let's make this as if it were going to be separate sheets. So if I was trying to do the cube, I would have 6, including the plate. Alright, so in effect this becomes sheet 1. One of the other advantages of the virtual component is until I save these out, it's fairly easy to change the name of these subcomponents as long as I don't do anything to the top level assembly name. Alright, so we need a front sketch. Find the location. Go over into the sheet metal. We'll generate a base flange tab. This is going to be an up to vertex. I don't have any surfaces or other geometry. Item of interest would be, is it interior or exterior? So let's reverse that direction. We have the 060 K factors. Well, we're not doing anything in the way of bends. If this was a complete bend, up, over, around, that would, kind of all of these parameters then come into effect. And so that becomes my first sheet. And then we add a second one. And edit. And front plane, sketch. Draw the line. Make sure that I'm in sheet metal, base flange. Same thing, we're going to go up to vertex. Check for the direction of the sheet metal, which way it's going, so we'll reverse it to the outside, and then I can accept it. Alright, so if it's kind of a jigsaw puzzle, if there is intersecting overlapping bins, this helps manage it and stay consistent with those builds. So we come back and we show the weldment, and we have some of that. So the next would be some top piece, and we could pick a slightly different naming structure if we needed it. Alright, so if I expand out and we hide all of those, because this is the assembly, I could also hover and hit the tab and shift tab to bring them back. So shift tab, tab to show. And then the last piece that I'll include in this is the subplate. So we have a base, and then I edit the base, and we'll stay with kind of our standard and we'll show. Alright, so even though I want this geometry, so let's see if that'll pick a select chain. So it goes all the way around. I can convert entities, features, extrude, and up to vertex. So this is kind of a consistency item. In definition, the sheet is going to be from about, well, down to mils. So maybe 10,000ths through about a quarter of an inch, and quarter of an inch, 0.250 inches is the crossover from sheet to plate. So depending on the material, depending on what you're working with, going up through the gauges and getting to that quarter-inch thickness, that'll let you know where the absolute crossover is from sheet to plate. So at that point, I'd go ahead and build in the rest of the holes, the geometry that I need for the pattern, and at the end, we hide the layout, hide the sketches, the support, and then let's see if we do Shift Tab and Shift Tab, and then on this one, since I don't have it expanded out, I'll just go ahead and do Show Components. Alright, so there's a lot left to build on this. I haven't seen that one before, so interesting. So I imagine that the double arrow means that since I pulled the chain off of the support sketch but then set the depth to the layout, I'm actually getting double arrows there, indicating that there are two references going on. Alright, so a lot of little visual clues still, and like I said, a lot left to work on to take it to this structure, but it gives you kind of the idea that we can separate these out, have a little more control if we need it, and we're gonna start accumulating a lot of parts. This might be the better way to go.